Ionic bonding, also known as electrovalent bonding, occurs when electrons are transferred between atoms, typically between metals and nonmetals. This type of bond forms when the valence electrons of a metal are transferred to a nonmetal. To understand this process, let's revise the atomic structure and the octet rule. Atoms consist of a nucleus, containing positively charged protons and neutral neutrons, surrounded by negatively charged electrons that orbit in shells. In a neutral atom, the number of protons equals the number of electrons, balancing the overall charge. The first electron shell can hold up to 2 electrons, while subsequent shells can hold up to 8 electrons each. Valence electrons are the electrons in the outermost shell of an atom. The number of valence electrons varies across different groups of elements in the periodic table. Group 1 elements have 1 valence electron, Group 2 elements have 2 valence electrons, Group 7 elements have 7 valence electrons, and Group 8 elements, also known as noble gases, have 8 valence electrons. Atoms are most stable when they have a full outer shell of 8 electrons, similar to the noble gases. This is the basis of the octet rule. The octet rule states that atoms achieve their most stable configuration when they have 8 electrons in their outermost shell. This principle explains why atoms engage in chemical reactions to attain a full outer shell. For example, in ionic bonding, metals will lose electrons to achieve a full outer shell, becoming positively charged ions called cations. They become positively charged because they have less electrons than protons. Nonmetals will gain those electrons to complete their outer shell, becoming negatively charged ions, called anions, due to now having more electrons. This transfer of electrons creates a strong electrostatic attraction between the oppositely charged ions, forming an ionic bond. Now, let's move on to naming ions and ionic compounds. It's important to understand how to properly name the different ions that form during ionic bonding. This helps us clearly communicate the components of these compounds. When naming a cation, which is a positively charged ion, we simply write the name of the element and add the word ion. For example, the ion formed when sodium loses an electron is named the sodium ion. When naming an anion, a negatively charged ion, we take the name of the element, replace the ending with "ide", and then add the word ion. For example, the ion formed when chlorine gains an electron is referred to as the chloride ion. When naming ionic compounds, we combine the names of the cations and anions. For example, when sodium ions and chloride ions combine to form table salt, we name the compound sodium chloride. Now, let's delve into the naming of transition metal ions. Most transition metals have a variable valency, meaning they can form different cations with different charges. This makes it necessary to specify the ionic charge when naming these ions. For example, iron can have a charge of either +2 or +3. As a result, we need to specify whether the cation has a +2 or a +3 charge by writing the ionic charge as a Roman numeral in brackets. Here's how it works. Iron with a +2 charge is called the iron 2 ion, and iron with a +3 charge is called the iron 3 ion. Let's look at another example with copper. Copper can form cations with charges of +1 and +2. We would name these ions copper 1 ion and copper 2 ion, respectively. This use of Roman numerals to indicate charge is called stock notation. Stock notation is used not only for transition metals, but also for lead and the metals surrounding lead on the periodic table. For example, lead can form Pb2+ and Pb4+. We would name these lead 2 ion and lead 4 ion, respectively. Now that we've learned how to name ionic compounds, we should also know how to write the formula for an ionic compound when given its name. Let's go through an example: magnesium iodide. Here's how you can work out its chemical formula. First, identify the charges of the ions involved. Magnesium is in group 2 of the periodic table, meaning it has 2 valence electrons and becomes a cation with a charge of +2 when it loses those electrons. So, the magnesium ion is Mg2+. Iodine, on the other hand, is a halogen with 7 valence electrons. It needs 1 more electron to achieve a noble gas configuration, so the iodide ion is an anion with a charge of -1. Thus, the iodide ion is I-. The total charge of the compound must be 0. To balance the charges, we will need 2 iodide ions to cancel out the +2 charge of 1 magnesium ion. Therefore, magnesium loses its 2 valence electrons to 2 iodine atoms. So the chemical formula for magnesium iodide is MgI2. Now that we've covered the basics of ionic bonding, naming ions and ionic compounds, and writing their formulas, it's time to test your understanding with a few questions. Grab a pen and paper, and let's see how well you've grasped the concepts. Question 1. Write the formulae for potassium chloride and copper 1 oxide. Pause the video if you need more time to think. Here's the answer. Potassium chloride is composed of potassium ions, K+, and chloride ions, Cl-. Since their charges balance out to 0, the formula is KCl. For copper 1 oxide, copper has a +1 charge and oxide has a -2 charge. To balance the charges, we need 2 copper ions for every 1 oxide ion. Therefore, the formula is Cu2O. Question 2. Name the following ionic compounds, MnCl2 and Cus. Again, pause the video if you need more time. Here's the answer. MnCl2 consists of manganese and chloride ions. Since manganese is a transition metal, we use stock notation to indicate its charge. In MnCl2, manganese has a +2 charge, so the compound is named manganese 2 chloride. For Cus, copper has a +2 charge when paired with sulfide S2-. Therefore, the compound is named copper 2 sulfide. Great job if you got those right. Practicing these questions will help reinforce your understanding of ionic bonding, naming, and formula writing. Keep practicing, and you'll master these concepts in no time. Thanks for watching. If you found this video helpful, don't forget to like, share, and subscribe for more chemistry content. Leave any questions or comments below, and we'll see you in class for our next lesson.